Welcome to another video of capital budgeting. Now, in order to overcome the shortcomings of the IRR or internal rate of return method, a new method known as the modified internal rate of return or MIRR was devised to evaluate projects for inclusion in the capital budget. Let's consider the following project. So here there is an outflow of 1000 rupees at the beginning, and then there are cash inflows for the next 4 years. Let's say that the cost of capital is 10%. So cost of capital is represented by K. So K is 10%. Now the MIRR method assumes that the cash inflows that we receive are going to be reinvested at the cost of capital. So this cash flow of 500 rupees will be reinvested at K equals to 10% for the next 3 years. So this value at the end of the 3 years, or in all at the end of 4 years, let's say becomes FV1, future value 1. Similarly, this 400 will be reinvested at K equals to 10%. This will become FV2. Similarly, this 300 will be reinvested. This will become FV3. K equals to 10%. And this 100 rupees will remain as it is because there is no more tenure for it to be deposited and gain interest. So this will be FV4, which will be the same as 100. So the sum of all these FV1 plus FV2 plus FV3 plus FV4 will be the terminal value. So the terminal value, or TV in short, is equal to FV1 plus FV2 plus FV3 plus FV4. Now we know that from the formula of compound interest, A is equal to P into 1 plus I to the power n. A is the amount that we are going to get at the end of the tenure. P is the amount which has been deposited at the beginning of the tenure. N is the number of compounding periods, and I is the rate of interest per compounding period. So in this case, if we take each cash flow, A becomes the future value. So let's say this is FV1 is equal to P is the present value or the cash flows value. So let's say this is PV1. 1 plus I is nothing but 10% or K, and N will be the tenure for which the amount is being deposited. So in case of the first cash flow, FV1, it is 1, 2, 3 years. So the terminal value becomes FV1, which is PV1 into 1 plus K to the power 3. PV1 here is 500. So 500 into 1 plus 10% will be 10 divided by 100, which is 0.1. 0.1 to the power 3 plus 400 into 1 plus 0.1 square plus 300 into 1 plus 0.1 to the power 1 plus 100. So this becomes 500 into 1.1 cube plus 400 into 1.1 square plus 300 into 1.1 plus 100. So this becomes 1579.5 rupees. So this is the value of all the future values of the cash inflows. So terminal value is 1579.5. So this terminal value is at the end of the tenure of the project. Now we need to find the rate of return or the rate at which the present value of this terminal value is equal to the project cost, which is this. So we have to take the present value of this terminal value such that this present value is equal to this value, or in other terms, the present value of the terminal value is equal to the present value of the cash outflows. And we have to find at what rate will that happen. So basically the present value of the cash outflows has to become equal to the present value of the terminal value of the cash inflows. And we have to find the rate at which this happens. Now present value of cash outflows in our case is 1000. So this is 1000 and this has to be equal to now present value of the terminal value. So let's take this case. So the terminal value has to be discounted for 1, 2, 3, 4 years. So n is 4. The future value is 1579.5 and we have to find the present value. So present value will be equal to present value is equal to future value divided by 1 plus I to the power n. Future value in this case is 1579.5 divided by 1 plus I is nothing but R, which is the rate of return, to the power n, which is 4 in this case. So or now let's take this 1 plus r to the power 4 on the other side and bring this 1000 on the other side. So 1 plus r to the power 4 is equal to 1579.5 divided by 1000, or 1 plus r to the power 4 is equal to 1.5795. Now let's take the fourth root of both the sides. So or 1 plus r is equal to 1.121, or r is equal to, now we'll take this 1 on the other side, so we get 0.121. So the rate is 12.1%. So this is the modified internal rate of return. So with this concept, let us now look at the definition of modified internal rate of return. So MIRR is the discount rate at which the present value of a project's cost. So as we had seen, the present value of cash outflow or the project's cost is equal to the present value of its terminal value. So present value of the terminal value, where the terminal value is found as the sum of future values of the cash inflows. So terminal value of cash inflows. And the future value is found out by compounding at the firm's cost of capital. So basically, in MIRR, when we are finding out the terminal value of the cash inflows, we use the cost of capital K. Similarly, when we find out the present value of cash outflows, we'll use the cost of capital K. But when we find out the present value of the terminal value of cash inflows, we will use the modified internal rate of return.